Hello, and welcome to the Essentials of FPGA Design course presented by VAI Logic and Xilinx. My name is Jimmy Costa, and in this course we will cover some of the fundamental concepts that you need to know to create FPGA designs. This includes the Xilinx device architecture, the design tools, and some synchronous design techniques. As you can see, we've got a lot to cover, so let's get started. One of the things we want to emphasize from the beginning is the importance of your design methodology. When we design FPGAs, we have three goals. The first, obviously, is for the design to function correctly. The second is for the design to fit in the smallest possible device and thus limit the device cost. Finally, the design has to meet our performance requirements. So here are some recommendations to ensure the best possible results. Always use synchronous design techniques. This simplifies timing analysis and produces more reliable and reusable designs. You can make sure your design is optimized by using appropriate HDL coding styles and targeting the resources available in the device. Also, it is important to understand how to effectively use the synthesis, implementation, and simulation tools. As we proceed through this course, please keep these guidelines in mind. Doing so will allow you to create designs that meet your performance objectives, fit into your specified device, and are reliable and reusable. Generally speaking, using an effective design approach will enable you to create the most optimal design. As you can see, this is the FPGA design curriculum path. We offer a number of other courses other than this Essentials of FPGA Design course. Topics include DSP, connectivity, embedded, as well as advanced FPGA classes. The class that immediately follows this is the Designing for Performance course. And in that course, we go into more detail on the FPGA architecture and some of the techniques that you'll need to know to create high performance and optimal designs. So let's take a look at the specific objectives for this course. First, you will be introduced to the primary features of the Xilinx FPGA architecture. You will then be introduced to the Xilinx ISE design tools, and you'll learn how to both implement a design on an FPGA and simulate your design to ensure that it is functioning correctly. You will learn how to read the various reports that are generated by the tools and determine whether or not your design goals were met. You will use the wizards included with the tools to generate clocking resources, make pin assignments, and to create global timing constraints. As you can see, this course is a mixture of lecture and labs. The labs are intended to reinforce the lecture content. The main lecture modules included in this course are Basic FPGA Architecture, Xilinx Tool Flow, Reading Reports, Global Timing Constraints, and Synchronous Design Techniques. 4 labs are included with this course. Lab 1 is a Xilinx Tool Flow lab. Lab 2 is the Clocking Wizard and Pin Assignment lab. Lab 3 is pre-assigning I/O pins using the I/O planner, and Lab 4 is a Global Timing Constraints lab. So that's the agenda. After this class, you should have a good idea of some of the essential techniques that you need to understand in order to create FPGA designs. But if you do have further questions, there are numerous resources available to you. For each device, Xilinx publishes user guides and data sheets that document the functionality and performance of the devices and their specific resources. Also, Xilinx maintains an answer record database that records solutions to various problems. This is your first line of defense if you have an issue. Search the answer browser. It is likely someone else has had the same problem as you, and it's been solved and documented in the database. Now, back when I first started using FPGAs, which was in the late 90s, they contained really only logic resources and I/O resources, and we used them mainly for prototyping ASICs. These days, they contain many different types of resources, and as we will see in this next section, these are not your grandpa's FPGAs anymore.